Hello everyone, welcome to my next tutorials related on SetForce software. We have already discussed about the SetForce our previous tutorial. Who has not seen it, my previous video, please check out the playlist. And before start of my tutorial, who has new on this viewer, I want to introduce myself. I am Sahil Verma, working as application engineer, well-known company Impulse Technology. Impulse Technology, you can see number of the customers working on the set force as well as Nanodecal and Rescue. And our company have partnership with SJW and Nanocadmium Technology and Flux. And you can see we have various type of products who are working on molecular modeling, visualizations and multi-scale simulation platforms, though they can use the different type of softwares. And for the materials properties, you can use rescue softwares, advanced quantum chemistry software for molecular calculations and electronic structure analysis. You can use these MOMEP and BDF softwares, and advanced quantum transport calculation software for the nano device simulation and analysis. You can use NanoSkin and NanoDecal. And in here we are going to discuss about the solar cell software. So it is developed by the Fluxim Ag, and it is a QTCAD, advanced quantum device simulation software for modeling atomic scales, superconducting and solid-state qubit device enable analysis of quantum state and device performance. So basically, our company that are working on the distributor parts, and so if you want to use this type of software and if you are working on that type of project, you can directly connect with us. It is a continuous series related to the SetForce software. In here, I will show you how you can plot contours, graphs, and their data. I will take one of the examples and then you can plot. We are going to open SetForce software. So it is a GUI of the SetForce software. Who has not seen it? My first video and my series related to the SetForce. Please see that all the videos so you can know how you can use this SetForce software. So what is the actually meaning of this tab? So it is a new where you can create your new projects, and it is a existing example where you can see these are the both tabs. You can save your projects it for the examples in here you can see, and it is for the layer stack, and it is a material database. SetForce added new material database, so you can see that if they are useful, so you can take any one of the materials. You can see a lot of the materials are given in here. It is a passive optics, and SetForce have 5 modules. It is a absorption modules, it is a emission modules, it is a scattering modules, it is a drift fusion modules, and it is a thermal modules. So these are the 5 modules. We have already discussed about these modules in a previous video. And it is a input tabs where you can create different type of inputs. So we are going to explain about how you can plot one of that contour plots. First, I will take one by one each layer names, and you can add layer from these tabs, and then you can give one by one name. Like first it is a air, second layer it will be glass. You can take it totally depend on the user which type of layer they want to consider. I'm taking examples and tutorials value, so you can follow that steps. You can take one of the active layers as a front active layer, you can say. Then you can add JDNO. After this you can add one of the interface generally used for interconnections of this type of layers, and it will help to the recombinations and movement of the electrons and holes. Generally you can say it will help to cross the barriers. Okay, dot. And bottom active layers, generally result will depend on that refractive index layer and electrical material files. It not depend on that layer names, but format need to be correct basically. Now you can add one more layers. It can be a surrounding or cover you can take. So it is just a layer names that you have given. Now you need to provide one by one each of the thickness value. Like for glass, you can take 1 mm because unit is given in here. One of the conducting oxide you can take as per example value, and in this layer you can take 10 mm. For the active layers you can give 192. For this layer you can give 81. It is basically that's follow that whole theory parts, how the STL and ETL layer they are working on active layer part. So it is just a simple tandem organic solar cell examples we can say. And P dot PSS you can give in the 15 mm. Back active layers you can give in the 208. And PFN layers you can give in the 5. And aluminum you can give in the 70. And cover you can give 0 because top and bottom layers that thickness you can take 0 because they are not wavelength dependent you can say. And which layer which is wavelength dependent, so one by one you need to import the refractive index files. It is supported .nk files, but glass refractive constant you can take 1.5. For ITO you can take ITO.nk, and you can see this is the materials parts where a lot of the materials given. In my previous video we have already explained if that materials are not available, so you can visit on the research papers as well as the edit tabs, and also you can work on that material softwares. One by one you can import refractive index file because result will depend on that refractive index files and as well as material files. For PFN you can give any other refractive constant value and imaginary parts will be 0. For aluminum you can import al.nk. In edit tabs you can see that scripts. You can give any of that so your own parameters, and you can create in your new files as well as you can save, and you can see that ranges, exports, files tabs in here. You can see in here the step preview and in here layer name, thickness, and we have imported refractive index files. Now you need to activate drift diffusion module. In drift diffusion modules you can calculate electrical parameters, and you need to activate absorption modules. In here you can calculate absorption parameters. Now you need to provide one by one each of the input value. In here you can provide that inputs. ITO are taken as a electrodes, and work functions you can give in here the 5. You can see different junctions models are given: ohmic, thermonic organic, thermonic inorganic, and boundary conditions. And in the bottom sides you can take aluminum as a electrode, and you can give any other work functions 4.1. So in between you need to provide semiconducting files. That means semiconducting parameters like density of states, energy level, effective density, dielectric constants, spectral doping, donor doping, layer polarity, and mobility parameters. Excitant you can see radiative decay rates, non-radiative decay rate, generations, saturations limits. So you can provide that different inputs. Traps parameters like defect parameters, if you want to put, you can put in here. Degressions models, you can see. So these tabs are also available, and in that sector and donor and empathetics, that mean net price. Mobile ions, cation calculation, if you want to do, you can do. You can provide one by one each of the value if you have that, and it is a recombinations parameters, and tunneling features also included in here. If you want to give that tunneling features value, you can give, and impact ionizations, so you can also give that value. But if you have that file, so you can directly import that parameters, like in here supported .em files, so you can import. Now you can see that energy levels, and after this same you can give these files. You can check automatic value have fill in here. Zdno. Now you can give in here the interface. It is a electrical interface, but if you activate a scattering module, so scattering interface also will be active. You can see coated interface and geometry, different type of geometry, 3D ray tracing, and different models you can check. But we are not focused on this scatterings modules, but we are majorly focused on that electrical interface. You can see excitant dissociations value you can give, but we need to provide in here that hopping, so you can give in here the hopping value one by one. You can give one by one each of the value. 1 exponential minus 20, 2 exponentials minus 5, Lumo Homo you can give 1 exponential minus 20, 1 exponential minus 20. You can give that value, and unit will be same meter square per seconds. And you can activate the electrical field barrier lowering tabs. Now you can select pedot at semiconducting layers and import that same pedot.ps files. Same process you can apply in these files, back active layers, and so like this you can give one by one each of the value. Move with that absorption setting tabs, and you can check shift single wavelength. You can take range if you want to change, as if you can select 300, so you can select and 900. Step if you want to increase and decrease it for totally calculations parts, and you can check intensity scalings and sun spectrum files, so you can select this type of value and move with the electrothermal settings. You can see steady state, transient, AC, intensity modulated photocurrent spectroscopy, and intensity modulated voltage spectroscopy. So if you want to do different electrical part calculations, you can do. And electrical source currents, so it totally for device operated voltage you can give in here 1 volts. Temperatures you can select in here the 300, and just taking examples value I'm considering in here. Trapping features you can enable, doping you can enable. In bottom side if you will move, you can see electrical circuit settings. So if you want to create this type of circuits and external loads, if you want to connect, you can give in here. Like device area you can give 4 mm squares, and para resistance you can give 30 kilo ohm. And now you can active shift settings. You can see layer stacks and energy levels they have created, and you can add. You can take voltage, thickness, thickness. Like this, if I want to shift any one of the parameters, you can select. It totally depend on the users. You can see number of the parameters they have given, electrical material, phi, strap, recombination. So it totally depend on the users. That input you have provided, you can shift according to that ranges. And linear logs, if you want to change, you can select. You can take in here the ranges 0.8, 1.2. You can select in here the step value 150 and 250. Step you can consider in here 5 or 1, totally depend on the users. 150, 250, and you can take in here the steps. And that's steps they have changed. Now you can check in the script parts if you want to change any one of the parameters, you can change in here. Like air, glass, ITO, because it is a editables in here. And that value you have selected in input tabs, they will automatic selected in here. And you can see on the script parts. You can give in here the name of your projects like contour plots. Also you can give in here the names tandems, organic solar cells. If you want to give, you can give. And then you can click on the buttons. It will take some time. You can see simulation has been finished, and some of the errors that have given, I think we have not reduced some iterations part like discretizations and delta and elements. Therefore, it is showing like this. But result has been come. You can see built-in voltage, circuit current, current balance, and device currents, electrical power and power conversion efficiency. You can see electrical key figures, and you can see current maximum power density. And if you move with this, so at the same tutorials, when you move on this tutorial parts, this tutorial you can see global optimization of the current configuration, and we follow this tutorials. And in the bottom sides you can see this contour plots we are going to plot in here because number of the users asking how we can plot these figures. So we just follow this step, and this is the same, but first you need to collect this data. Move with this save visual data and go with this local C downloads, and you can choose this paths and give in here that names current data, and you can save these files, and you can check on this download tabs in here. It is the current data you can see. So it is the same plots you can see in here. Different value you can also see in these sites. And one more step you need to do in here. Now you can activate optimizations mode. Click on this optimization settings and select here one by one each of the parameters. First you can go with this thickness parts. Then again you can select back active layers thickness, and in here you can select voltage, and in here you can move with this local search with globals for better and accurate results. And now you can give in here the minimums and maximum range 150 to 250, 150, 250, and voltage you can give in here same range 0.8 and 1.2 you can give in here. And when we move on this target, so you can see minimum photo current. When you selected that active layer because you targeted this layers. When you move on this options tab, you can see optimizations. You need to set that convergence criteria and what type of optimizations method precisions you have selected. So you can click on this, and you can give in here divergence rectangles and precisions you can take in here 1 exponential 7. Max iterations you can take 100. It's just for the convergence criteria, and that's you can see linear you can select. All the things will be same, but only you need to disable shifts and enable that so optimizations. Only these things you need to be select. And then you can click on run buttons and simulation has been started in here, you can see. And this type of results you can see: display optimization, display key figures, error evaluations, contributions, and this is the key figures data, band diagrams, charge density, charge generations, current, electrical field, mobility, potential recombinations, and trap capture rates, numerics, the same, absorptions profiles one by one you can see in here, refractive index, white absorptions profiles, white spectral absorptions. You can also save same as the image and data forms. Spectrals you can check. It is showing like this because when you move on this absorptions, you have selected one step. So according to this, the value have coming in here. You can see that layer absorptions data, reflectance data, stat contributions, and transmittance. So this is the results related to optimizations. You can see this type of results like chi-square value, optimized parameters value. If you move with these optimizations and if you not selected that tandems and you directly selected any other targets value like electrical key figures data, and then you can target circuit electrical powers or optical data if you selected. So and if you want to import any files like this, like if you selected any other charge generations and save in data, and when you move on this and you can directly select, and you can see charge generations file is not defined, so you can directly import your files and you can target. So it totally depend on the users which type of settings they want to do, so they can do. But when we move on this chi-square value, so chi figures and optical parameters value, and you can create one of the optimizations key figure data files. You can copy this data and move with this notepad types and paste like this. Given here that's 200 to 33.33, and after this you can give another one and you can save optim key data, and you can also save these files in that download portion, and they have saved. That type of steps you can follow, so you can see that results. Now we are going to plot contour plot that you can see on set first tutorials parts like this. You can see this type of plots. So limited photocurrent at short circuit conditions, sweep over top and bottom, absorber layer thickness, we are direct global optimizations. I will show you how you can plot this type of image, you can say. And first you have already saved current data, and then you have already saved this optimized key figure data, like in the download folders you can see current data and opticum key data, and it is a current data you can see with a active layer thickness. So you need to create one folder, and after this you need to import that project on this. Give me the folder names, global optimization, and you need to put this data on this folder. So first you can copy this and paste. Again you need to paste this data, copy and paste. Now you need to open this, and you can see in here the optimization contour.py. It is a algorithms and scripts that mention in the set first tutorial. So you need to copy this, copy. I will show in the VS codes, and then you can paste this. And at the last you need to paste your project. So you can see it is a set first, and you need to copy this projects contour plots at the same projects, copy and paste. So now you can open VS Code where you can plot this script, and you can see how you can put the data. So you need to open VS Code. You can select these folders, and when you click on this optimization.py, you can see that type of scripts. I will attach these scripts on descriptions, so you can check. So you can copy these scripts, and you need to notice in here current data .txt. So you can give here that file names, and when you move on this side, you can see optim key data.txt, optim key data txt. So you can also check on the tutorials. Tutorial already mentions one. You can follow these algorithms and then you can plot. So now you can run these scripts. So after this, you can see your contour plot, and when you move on this, you can see. And when you form another algorithm, you can also mention in the cross at that provided scripts. You can use this type of external scripts, and then you can plot this type of graph. You can plot this type of contour data, and you can see this is the active layer thickness, and it is also active layer thickness and currents. You can check on this ranges as well as. So I hope you got my tutorial, and different type of examples are already given in here. If you want to explore more, so you can directly connect with us. And who has not seen it my previous video, please check out the playlist. My email are also given. If anyone has that query related to this, please directly connect with us. Thank you very much.